The automobile industry is on the hunt for a compact yet powerful engine. Traditional small gasoline engines often fall short, while diesel engines are typically bulky and heavy. Enter LiquidPiston, a company poised to revolutionize combustion engines and mobility. But what makes their engine so special, and how does it work? Let's dive into how this tiny powerhouse is set to transform the entire auto industry. Following closely on the heels of Mazda's announcement of its all-new Wankel engine, we have another exciting development in the world of rotary engines. LiquidPiston, an innovative engineering firm backed by the U.S. Pentagon, has introduced the XTS-210 engine. This groundbreaking engine is designed for a wide range of applications. The XTS-210 engine is nothing short of extraordinary. It's a 25-horsepower, two-stroke, supercharged, liquid-cooled 210 cubic centimeter rotary engine that reimagines the traditional Wankel design. Unlike the Wankel engine, which features a triangular rotor within an oval-shaped housing, the XTS-210 boasts an oval-shaped rotor inside a triangular housing. This unique configuration results in fewer moving parts, reduced friction, and a higher compression ratio. Adding to its innovation, the XTS-210 employs a patented thermodynamic cycle known as the high-efficiency hybrid cycle, or HEHC. This cycle merges the best aspects of diesel and gasoline engines, allowing the engine to operate on various fuels, ranging from gasoline to diesel to jet fuel, while achieving high efficiency and low emissions. So, in late 2022, LiquidPiston actually secured a $9 million contract with the U.S. Army to develop a prototype based on the XTS-210, which is specifically designed for military use. This prototype, which is expected to be ready by 2024, will be tested on a hybrid electric vehicle platform. The Army's goal here is to replace its current diesel piston engines with something significantly smaller and lighter, up to 80% smaller in fact. Honestly, this represents a monumental leap in engine technology, kind of like the transition to fuel injection. Creating an engine that maintains high power output on a larger scale required some pretty complex engineering and innovation, and that's a challenge LiquidPiston is really well equipped to tackle. With over a decade of experience refining rotary engine technology, backed by various government agencies and private investors, the company has actually showcased its engines across multiple platforms, including drones, generators, and motorcycles. LiquidPiston claims their engines can deliver up to 10 times more power density than conventional engines, producing more power with less weight and size. The XTS-210 from LiquidPiston is set to redefine what's possible in engine technology, offering a compact, efficient, and powerful solution that could honestly reshape the future of mobility. Back in 2003, Dr. Nikolai Shkolnik and his son, Dr. Alexander Shkolnik, came up with a brand new thermodynamic cycle that really had the potential to change the world of combustion engines. They called it the high-efficiency hybrid cycle, or HEHC for short. This cycle cleverly combined the best features of both diesel and gasoline engines, things like a high compression ratio, constant volume combustion, and overexpansion. On top of that, they designed an engine that could actually use this cycle, and it had a rotary configuration. They decided to name it the X engine, and they patented the design in 2004. After this big breakthrough, they went ahead and founded LiquidPiston Inc., a company focused on developing and bringing their innovative engine technology to market. Jump ahead about 20 years, and this technology startup, which, by the way, has been recognized by MIT Popular Science and even is now operating out of a 12,000 square foot facility in Bloomfield, Connecticut. Here, they design and test their engines with some really advanced equipment and software. Most of their production happens in-house, using CNC machining and assembly, and they also take care of software engineering and modeling for the engine systems. For certain parts and materials, they team up with outside partners. While LiquidPiston's patented HEHC design remains a crucial part of their technology, they are now exploring fuel energy conversion solutions for various hybrid power systems. This includes applications for unmanned aerial systems, mobile power generation, and auxiliary power units. These applications require compact, lightweight, efficient, and multi-fuel capable engines that meet demanding performance and environmental standards. LiquidPiston's engines are designed to meet these requirements, and, honestly, they offer up to 10 times more power density than conventional engines. Moreover, LiquidPiston is determined to establish itself as a global leader in scalable combustion engines. This objective has drawn significant attention from the U.S. So, in terms of performance, the 25-horsepower XTS210 relies on a supercharger to deliver 1 bar, that's equivalent to 14.5 psi, of boost, and, this boost can actually be adjusted all the way up to 1,000 horsepower if desired. This results in what's described as smooth power from a lightweight package that's roughly the size of a basketball. The engine also has a high power-to-weight ratio, which is really important for applications that need high power density and low weight, like drones, aircraft, and electric vehicles. Now, returning to the U.S. military's interest in this sports ball-sized yet fully scalable platform, there are 4 major market requirements that the XTS210 had to address. First up, portable and configurable. The XTS210 can operate in both engine-only and hybrid electric modes, depending on the application and power demand. It's also capable of running up to 7,000 RPM, which is just ideal for small lightweight electrical machines like generators, motors, and inverters. This enables increased mobility for hybrid applications, such as drones, vehicles, and aircraft. And get this, the engine provides 5 times the power-to-weight and power-to-volume density, and up to 3 times the torque-to-weight performance compared to traditional diesel engines. So, the XTS210 is designed with military-grade robustness. It can rely on either compression ignition or spark ignition, depending on the fuel type. This makes it compatible with diesel-like fuels, such as JP8 or Jet A, as well as gasoline-like fuels like ethanol and methanol. This versatility really enables excellent performance without compromising reliability. Liquid cooling allows the engine to maintain optimal temperature and operate at higher compression ratios and boost pressures, which ends up improving efficiency and power output. This is especially critical in hot climates where air-cooled engines often fail. The XTS210 is optimized for JP8 and Jet A fuels used widely by the United States military and aviation industries, but it can also run on gasoline, diesel, ethanol, methanol, natural gas, propane, hydrogen, and even biofuels, giving it, honestly, unmatched adaptability. LiquidPiston doesn't just aim to develop the XTS210 into a range of auxiliary power units for land, air, and marine vehicles. Their ambition is to establish this rotary engine as the most reliable and practical power source globally. They want it to be so sturdy and user-friendly that both commercial and military applications can seamlessly integrate it. Furthermore, they plan to explore mobile electric power generation and use it for hybrid electric propulsion in vertical takeoff and landing aircraft, as well as small unmanned aircraft systems. In the near future, LiquidPiston is working on delivering an XTS210 prototype to the United States Army, probably around 2024. While the company has previously developed various rotary X-engine variants for military use, this supercharged basketball-sized version really appears to be the most promising among all their options. LiquidPiston hopes that its XTS210 engine will, revolutionize the rotary engine market and offer a viable alternative to piston engines for various applications. The company believes its engines can be used for electric cars, urban aircraft, drones, vehicles, and power generation. They also plan to license their technology to other manufacturers and partners who are interested in using these engines for their products.